Today we will discuss deterministic push down automata. In last lecture already we have seen push down automata and what are the tuple are there, and in this lecture we will see what is the deterministic push down automata. This is the same thing whatever push down automata. This deterministic push down automata is a variation of push down automata and it is accepted by deterministic context free language. So, in Chomsky hierarchy already we see that CFL regular language, CFL, then CSL, then unrestricted language, like that, and here CFL language we divided in two part. One is DCFL, another is CFL. Then whatever DCFL language, that is accepted by the deterministic push down automata. Then what is the deterministic push down automata tuples? These are same things here: Q input alphabet, tau, Q0, Z, del is the transition function and F is the final state. And here is the same tuples like push down automata, but here is the some constraint is there. A is deterministic, then it should be satisfy Q belongs to Q. You see here Q belongs to Q. See, Q belongs to Q and A belongs to input alphabet and X belongs to tau stack symbol. Then we have Q A X has at most one transition. There will not be more than one transition from Q A X. If it is there, then it will be not in deterministic push down automata. For example, suppose we have taken one Q0 is a state in Q0, then here we are taking input as A, then stack top is suppose X, then we are pushing this one AX and going to Q1, then another same thing, suppose we will take here A, this is input A, stack top X, then after that X, here is the no operation. Means in Q0 we are taking input A and stack top is X, then after that, after the processing again we are going to Q0 and stack top is remain same, this means no operation. Then another same transition Q0 input A, stack top is X, again we are pushing here AX. For same input and same stack symbol we have two operation, one is push operation, another is no operation. That is why this is not allowed in deterministic push down automata. In this extent, for any Q belongs to Q, A belongs to input alphabet, X belongs to stack symbol, then Q A X has at most one transition, means maximum it will be one, not more than one. Then another is given if Q epsilon X, if you have not read any input and your stack top is X and it is going to any other state, then here Q A X should be 5 for all input. If once you have your stack top is X and you have taken any, you have not taken any input and going to any states, and then Q for all input Q A X should be 5, it will not go to any other state. This is the deterministic push down automata tuples, and here is the this should be, these two conditions should be satisfied, all the deterministic push down automata whatever we will design. Let us take an example. Suppose we will take an example here. One language will check that suppose 0 to the power n, 1 to the power n, then n is greater than equal to 1. Suppose this language we have given either we can design in deterministic push down automata or not, we will go for this. Let us take, we have to design what are the strings generated by the grammar. Strings, this language strings are you see here what are the strings will be generated here 0 1, 0 0 1 1, 0 0 0 0 0 1, like that. This is equal number of 0 and equal of number of 1 will be generated by the language. Though, so we will go to the deterministic push down automata. How this is a deterministic push down automata? So, we have to take here q 0, suppose we have started from the q 0 which is initial state, then after you know that our stack top is j, stack bottom is z, another tuple is there, that is stack bottom. So, we have to take here, if stack is empty, then we are getting here 0 input, we are getting here 0 input, then this will be 0 will be pushed into the stack. For all 0 we have to push, for all 1 each one we have to pop 1 0. So, here another 0 is coming, then stack top is 0, then push 0 0, 0 0 will be pushed into the 0 will be pushed into the stack. Then after this is 1 1 input, stack top is 0, then this is epsilon. You have to pop the 0 from the stack and go to the q1 state, and here same thing you have to make it loop 1 0 and this is epsilon. So, every one, each and every one you have to pop 1 0 from the stack. So, at the end if it is epsilon and z, then this will be z, then go to the qf. qf is the final state which is accepted state. qf is the final state which is accepted state. Then you can say this is a deterministic push down automata, and you see here when you are taking q 0 0, each and every transition is totally separated. You can say here what are the transition here, q 0 and this is 0 and this is z, this is push 0 q 0 and this is 0 z, and here is the q 0, another transition is there 0 and stack top is 0, then it is q 0 0 0. This is push operation, these are push operation. Then q 0, this is 1, stack top is 0, then you have to go to q1 and this is epsilon, you have to pop it, this one you have to pop it. So, here another transition is there q1, this is 1, stack top is 0, then you have to q1 epsilon, then this is q1 epsilon. These are the transition function, these are the transition function, and here at the end q1 epsilon and z, it is going to q a final state. So, see all the transition are unique, there is no, here is the q 0 input is 0, stack top is z, and here is the input same, but stack top is different. So, this will be separate from these two are separate transition. So, this is a deterministic push down automata, this is a deterministic push down automata. So, we will take a string, how this is accepted by the diagram. Already last lecture we have seen in how PDI is accepted the string. So, here we will take a string 0 0 q 0 and string is 0 0 0 triple 0 triple 1 and this is stack is z. So, we have to start this one, this is q 0 and input is triple 0 triple 1 and z. Now, you see your stack top is 0, stack top is z, input is 0. What you have to do? Go to q 0 and push 0 into the stack. Next, this is q 0 and this is 0 0 1 1 and 0 push into the stack, 0 push into the stack. Then after again your input is 0, stack top is 0, input is 0, stack top is 0. So, again you have to go to q 0 state and push 0 into the stack. So, now again you see you are in state q 0, input is 0 and stack top is 0. Then this will be again this 0 will be pushed into the stack. Now you see, when you are taking q0, now you are in q0 state. When you are getting 1, then your stacked up is 0, then you have to go to the q1 and pop 0 from the stack. So here is the q1 state, and you have to pop 1a from 1 0 from the stack, and your stack is now 2 0. So then after again same, what is the q1, there is a loop, you see here input is 1, stacked up is 0, then you have to pop 0 from the stack, and again same state you have to come back, then this is 1 0 z 0 z. Next again you are in q1 state, input is 1, stacked up is 0, again you have to pop 0, and this is q1 epsilon, and this is z, means already you have read all the input and go to the final state. This is accepted, go to the final state, this is accepted state, and here 000 111 is accepted by this deterministic push down automata, and you can say this language L is a deterministic context free language. Whatever language accepted by the deterministic push down automata, this is a deterministic context free language. So here these two are push operation, these two are push operation, then this one is these two are pop operation, this is pop operation, these two are pop operation. Like that we have see here all are unique transition, there is no more than one transition is there any state, all are unique transition here. So this is a deterministic push down automata. So language 0 to the power n, 1 to the power n, there is a comparison between the 0 1, that is why this is the deterministic push down automata. Now we will go to the another example, we will use here no operation. See here another example is given. Suppose L is given a to the power n, b to the power m, and c to the power n. N is greater than 1 and m is greater than 1. So here this language is given. So we will check, can it be designed by deterministic push down automata or not, we will go to that. If this language is given, either we will have to design in a deterministic push down automata or not. So take first call it some string from the language, what are the strings are generated by this language. So write some strings, what are the strings here, if n is a 1, m is 2, like that, this is a string ABC, and here this is also a string ABC, and you can say this is also A, B, B, C. So like that what it is happening here, A and C are comparison, there is a comparison between A and C. You can say here equal number of A and equal number of C is there, in between number of B is allowed, any number of B is allowed, and you have to take the equal number of A and equal number of C. Equal number of A and equal number C are there, and in between A and C any number of B is there. So what is the concept here? First all A you have to push into the stack, when B will come then go to the no operation, then only read and no operation, and each C you have to pop 1A, like that you have to make stack as empty. So how to design this? See, this is the concept. See here, we will take here q0 as a initial state. First of all A we have to push into the stack, for all A we have to push A into the stack. So here this is A Z, this is A Z, then A will be pushed into the stack, A will be pushed into the stack AZ, then after if any number of A is there, then it will be pushed into the stack, then AA, then after if B is coming, then you have to make the state, change the state, then B is coming, then definitely it will be A will be top of the stack, then it will be remain same. It was B input, you read the B input and stack top is A, then it will be B, A will be on the stack top, then go to the Q1. So, in Q1 you see maybe only you have read one B, maybe any number of B will be there, then what you have to do, make a loop here, B A no operation, B A no operation. For all B you read only B and stack top is A and go to the next like that, no need to, no operation here, no need to push or pop. Then when C will come, then if C will come, C each C here A stack top is A, then epsilon, then pop A from the stack, then here Q2 you have to go to the here loop, C input alphabet is A, then epsilon, you have to pop all A for in each C, then stack is empty, epsilon Z, and this is QF which is accepted, QF is the final state which is accepted. So, this is the diagram deterministic push down automata for this language A to the power n, B to the power m, C to the power n. Now, you check here all the transition are unique, there is no A in stack top is A input A, then stack top Z input A, then stack top A input is B. They all are different transition in each and every state, then this is a deterministic push down automata. So, take a string, how this is accepted by this language. This language you will take a string, any string, suppose you will take here A, one string A, B, B, and this is C. This string should be accepted by this diagram also, because this string generated by the language L. So, here we start, here is the state Q0 and you have to take here input is A, B, and C, and here stack is Z. This is input, this is stack is from initialize your stack is Z. So, in Q0 is the initial state, stack top is Z and input is A. So, read A first, see in Q0 you are getting input A and stack top is A. What you have to do? You have to push A into the stack. So, here Q0 and this is A, B, C, A, Z. I have to push A into the stack, again this one will be in Q0 state. Then Q0 A, then stack top is A. You see in your Q0 state input is A, stack top is A. So, what you have to do here? Again it will be push operation. So, here B, C, A, Z, you have to push it. This is push operation. Next, you see here, next input is state is Q0, and Q0 input is B and stack top is A. You see here, when input is B, stack top is A, then stack top remains same. This means there is no operation on in the stack. Whatever A input is there, that will be remain same. So, here B, C, A, Z. Sorry, this is Q1, we are going to Q1, this is Q1. You are going, is this Q0, In B we are changing the state, this is Q1, this is Q1. So, now you see in Q1 input is B, stacked up is A, input is B, stacked up is A, then this is Q1 and here B, C, C, A, Z. No operation, input will be remain same, whatever stacked up was there that will be remain same. Next again Q1 input is B, stacked up is A, then again same operation, you have to no operation, do no operation, C, C, then A, Z. So, next Q1 input is C, Q1 input is C, stacked up is A, then what you have to do? See here, input Q1 input is C, stacked up is A. So, what you have to do? Pop 1A from the stack. So, we have to go to the Q2 and here C A Z, pop 1A from the stack, 1A from the stack. Next you see, next Q2 and this is C, Q2 this is C A Z, and again you have to pop 1A from the stack. Then after this is Q2 epsilon and Z go to final state. This is QF, this is accepted state. This is the accepted state. So, here you see this is a deterministic push down automata. So, you can say this language is a deterministic context free language. So, here we have push operation is here no operation. Which one is the no operation? I am writing the state transition here, no operation transition, no operation transition, no operation transition. What is the no operation transition here? Q0 input is B, stacked up is A, then Q1 this is A, another is Q1 B and A, this is Q1 A. These two are no operation, these two transition are no operation, no operation transition, just we read B and go ahead to next input. So, here see all the strings of equal number of A and equal number of C is accepted by this language. Inside this, in between A and C, any number of A, any number of B will be there. So, if it is sometimes it will be ask you that n greater than equal to 0, what you have to do? So, if n greater than equal to 0 is there, then you can take one in transition from the Q0 epsilon Z go to the accepted state. Otherwise, you can do here like that simple modification, initial state may be final state sometime you have to do. Otherwise, in this diagram you have to do Q0 epsilon Z and go to QF. If nm is greater than equal to 0, this means epsilon should be accepted by this diagram. But in this question it is not, epsilon is not there, here minimum string will be A, B, C, then after any number, minimum length of the string is A, B, C. So, this is the deterministic context free language. So, there are many example, you can see another example here, you can do, you can try this question, A to the power n, B to the power 2n, this is n greater than equal to 0, and this language also a deterministic context free language, and this will be accepted by the push down automata. And also this is one language A to the power 2n, b to the power n greater than equal to 0. This is also a language which is accepted by the deterministic push down automata. And suppose another language is given a to the power m plus 1 and this is a b to the power a m. This is also a deterministic push down automata. For this type of language we can have deterministic push down automata. So, all the deterministic whatever the language is accepted by the deterministic push down automata, then that is called also context free language. If any deterministic context free language, if any language is not accepted by the deterministic push down automata, then you can say this is not a deterministic context free language. And here is the while I will be talking about the non-deterministic push down automata, we will see that it is different kind of like NFA, DFA. NFA, DFA are equal, but deterministic push down automata, non-deterministic push down automata are not equal, and some language will be accepted by the deterministic push down automata and some language will be accepted by the non-deterministic push down automata. So, these are the reference book. Thank you.